Hey, this is going to be the explanation for the laundry detergent experiment, which was your first attempt at designing a controlled experiment. So, this experiment is about laundry detergent. Traditional laundry detergents contain chemicals in them called phosphates, and those phosphates are very effective at removing the stains from clothes. Unfortunately, they have a side effect, which is that phosphates are a very strong plant nutrient. So after the water in your washing machine is done washing the clothes, it gets sent back out into the environment. And if it has a lot of phosphates in it, then the algae and other plants that live in an aquatic ecosystem use all of those phosphates to sort of grow out of control. And so you have bodies of water that just have excess amounts of algae. It looks sort of like a fish tank that has just been in a state of disrepair and hasn't been taken care of. It looks sort of like all dark and scummy. And so not only does it look bad, but the algae can block the sunlight that other plants are trying to use, and it really disrupts the ecosystem in a bad way. Also, in some places, it allows toxic, poisonous types of algae to grow. There's a species of red algae that lives in the Gulf of Mexico that's poisonous. And whenever there are these large nutrient influxes into the water, those algae grow out of control and poison the animals that live in the water and poison the food that humans try to catch out of the ocean, clams, oysters, etc., and make them inedible. So this is a major problem. Now, honestly, this problem has already been addressed by the United States, and that phosphates in laundry detergents have been made illegal since 2015. They're not illegal in all countries. That's a country by country decision. But all detergents that you can buy at the store today should not have phosphates. However, for the purpose of this experiment, I would like to know whether or not these new detergents that you use, um, do they actually get your clothes as clean as the phosphate detergent that was used in the past? So that's what we're going with. The first part of any good experiment is to research and make observations so that you can form a hypothesis. So in this case, the first thing that I asked you to do was to research and identify one brand of laundry detergent that would fit into each category, one with phosphates and one without phosphates. Especially one that we might call an eco-friendly brand of detergent. And so hopefully you were able to go online and find an eco-friendly brand of detergent that you could identify by name that for sure did not have phosphates. And you could also research and find a brand of detergent that does have phosphates, even if it's not actually on the market today. I'm sure you could find the names of some detergents that even are still produced in America and sold to people in other countries. Just because something isn't legal to use in America doesn't mean that there aren't manufacturers that still produce this stuff and then ship them out and sell them to other places. So I'm sure you can get your hands on some phosphate detergent if you wanted to. All right, so that's number one. Number two is to state your hypothesis, and it said very clearly on here to be sure that your hypothesis includes a reason and to use the word because. And so a couple things you can do here. Your hypothesis is either going to be one of two things, basically, right? It's either going to be that the detergent with phosphates does work better than the detergent without phosphates in terms of removing the stains from clothes, or your hypothesis might be something like, well, I think that the two types of detergents are going to work equally well, and there won't be a significant difference between the two types. But you have to give a reason why. And so, what are some examples of some reasons why? Well, have you personally observed any difference in the quality of the laundry detergent over the last 5 years? Over the past 5 years, have you been at home thinking to yourself, man, my clothes, they're just not as clean as they used to be? Well, if that's true, well, that's an observation that probably would lead you to believe that the new type of detergent is not as effective as the old phosphate type of detergent. If you never personally made that observation and you didn't notice any difference, well, that might lead you to believe that there might not be any difference in the two types of detergent because you haven't noticed anything within your lifetime. Probably in the first part of your life, the first 10 years or so, your parents were washing your clothes with phosphate detergents. And for the last 5 years, they probably weren't. And so have you noticed anything? You could also go the route of doing some research, and you could easily find online how phosphate detergents work, that they bind to certain ions that are in the stains, and they work effectively to lift the stain off the clothes. And if you don't have the phosphates in the detergent, then maybe that degree of stain lifting from the clothes won't occur. And so you could use research from the internet to make your hypothesis. But if your hypothesis did not use the word because in it, and you did not state a reason why you thought it was going to be true, then that's just not a totally effective and correct hypothesis. All right. Question 3 says to identify the independent variable in this experiment. The independent variable is the one part of the experiment that you're going to change on purpose. And so definitely the independent variable in this experiment is that some of the clothes that you're going to wash are going to have phosphate detergent, and some of the clothes that you're going to wash are going to have non-phosphate detergent. And that's your independent variable, and that's the one and only thing that you are going to change in this experiment. All right. Number 4, identify the control group in your experiment. The control group exists as a comparison. I think in this experiment, instead of running 2 trials, that we should run 3 trials. We should have one group of whatever type of clothing you've determined you're trying to remove the stains from, one group that doesn't get any detergent at all. And we can use that as a baseline for comparison. So instead of running 2 groups, we could run 3. One group with just water in the washing machine, one group with phosphate detergent, and one group with non-phosphate detergent. This way, we can sort of see how much the washing process without detergent removes the stain, because I think it probably will some. Even if you put clothes in the washer and forget to put detergent in there, just the water and the motion of the washing machine will probably get it a little bit cleaner than what you started from. And so it would be nice to know how much of the washing process is actually being done just by the machine and by the water, and how much each type of detergent actually adds to the process. And so by setting it up this way with 3 groups instead of 2, we can really compare the effect of the detergent to a round of washing that just had the water. Okay. Question 5, I think I just sort of answered that in question 4. Explain the purpose of including a control group. The answer is always so that you have something to compare your experimental groups to. And so in this case, we're comparing using different types of detergent to not using detergent at all. So always, always, always include a control group for comparison in your experiment. Question 6, identify the dependent variable in your experiment. The dependent variable is what you expect to change as a result of changing your independent variable. So our independent variable is the type of detergent that we are using. So as we change the type of detergent, what do we expect to change within the experiment? Well, that would be how clean the stain got after the detergent was applied through the washing machine. So how much of the stain was removed or how clean the clothing got, that's our dependent variable. We're not changing that part of the experiment on our own. We can only change the independent variable and then let that change the dependent variable for us, and then we'll collect the results of the dependent variable as our data. Number 7, I asked you to try to explain how to measure your dependent variable using quantitative data. That means that your answers must have numbers to it. Got lots of different answers here. Some of them, I appreciate the thought that you tried to use numbers, but I want to sort of explain why I don't think it would work. Some of you said the number of stains. So if you made like 5 stains on each shirt and then counted the stains that were left at the end, what if one type of detergent made the stain lighter than the other type of detergent, but not fully gone? So that when you were counting up the number, both shirts still had 5 stains, but one was obviously lighter. In your quantitative data, the answer would be 5 stains on one shirt and 5 stains on the other shirt, and it wouldn't fully explain exactly what happened. Same kind of thing. Some of you said the volume of the stain, like each stain would have like the same exact size to it. Again, what might happen in this experiment is that the volume of the stain, the area of the stain wouldn't change. The size of the stain would remain the same, but the shading of the stain might change according to how well the detergent worked to remove it. So if you just measured the size, it would be the same before you started and after you ended. And that wouldn't really tell the story of how much the detergent actually worked to clean the clothes. So I think the best way and the simplest way for people like us to do this without fancy scientific equipment. I know that some of you said spectrophotometers, and you have fancy equipment that you could use to measure the shading results of the experiment, and that's all true. But for people like us that don't have access to more expensive equipment, one way that you could set up this experiment to analyze the data quantitatively is to do a shading scale. So that, say you started off with like a white t-shirt that you were going to stain, and you could assign that white t-shirt to the number 0, meaning that it's completely and utterly clean and there's no stain whatsoever. And then you could go all the way up to, say, number 10. Number 10 would be as dirty as you made the clothes to start the experiment. Say it was mud stains that you chose. The darkest mud stain that you put on there was a number 10. That's like how dirty it was when you put it in the washing machine. A 0 is how clean it was when it came out of the package. And so then you could make up a shading scale where a number 1 was just slightly dirty. Number 2 was just a little bit dirtier than that. And you keep going, number 3, number 4, number 5. Like number 5 would be like halfway clean, halfway less shaded than it was to start with. And you can keep counting up to like number 9. Number 9 would be like, oh, it's just like the smallest bit lighter than when we started. Number 10, it just worked like a tiny bit. So that whenever you got the results of your washing, you know that every shirt started at a 10. And then when you were done, you could sort of just take that shirt and compare it to the different numbers on the shading scale and sort of say, okay, that shirt's a 6, and that shirt's a 3, and that shirt's a 5, etc. And then you would have a number to go with how clean the shirt was, and you weren't just sort of using your eyeball to say, well, that looks cleaner than the other one. Now you would have actual numbers to use and data to use, and that makes your experiment a lot better normally. All right. Question 8 and 9 are probably the most important part of designing your own experiment, which is, can you think of all of the controlled variables that need to be kept before the experiment starts? Remember that you're only allowed to have one independent variable, which means that every other single aspect of the experiment that you can think of has to be kept exactly the same at all times. The problem is that if you forget to keep one of these variables controlled before you start, it can end up changing along the way and could end up ruining your experiment. So this is where the thought process comes in. You need to take some time and think, when I'm doing this experiment, what are all the things that could possibly affect the outcome, and how am I going to make sure that I keep them exactly the same throughout the entire experiment for every possible group? So I split this into 2 different questions. Question number 8 was, how about the things that you need to make sure that you keep constant while preparing the clothes? All right, so here's some of the things that I thought of. So first of all, you want the same kind of fabric, say 100% cotton. You want the same color of fabric, which would probably be white if you're trying to determine stains. Number 3 would be the same type of stain. Like you wouldn't want to put like mud on some clothes and grass on some clothes and chocolate on some clothes. You want to keep the same exact kind of stain, the same size of the stain, the same intensity of the stain. You don't want to start some off at a 10 and some off at a 5. You want to keep them all exactly the same. There's probably a lot more than that. There's just some I thought of off the top of my head. But see, if I was really doing this experiment, that's not good enough. I would have to stop and think for a while to make sure that I had every single possibility covered. So that's question 8. Question 9, moving on. How about during the washing process? What are some things that you should keep constant during the washing process? How about the same washing machine every time? How about the same number of, say, if you picked like a white cotton t-shirt, the same number of t-shirts per load? How about the temperature of the water every load? How about the spin cycle, like how fast it was going? Is it on gentle or is it on full speed? How long does the washing cycle go? Are you going to put them in the dryer or are you going to let them air dry? how long are you going to wait until after the experiment is over before you analyze the results? Going back to question 8, how long are you going to let the stains set in the clothes before you wash them? Is it going to be 5 minutes, or is it going to be 5 hours, or is it going to be 5 days? That goes back to question 8, something that I didn't think of at the time when I was giving you the answer that now I thought of that was really important, because obviously if you have the stains set for different lengths of time, it's going to affect how easy it is to remove the stain. So you got to think of everything. And what very few of you did on here that I would like to see you do in the future is to be specific when you give your controlled variables. For example, when you're writing the answer, you would say, some of you wrote, we're going to use the same kind of stain on each cloth, which is fine. But why don't you be more specific and tell me what kind of stain are you going to use? Okay, we're going to use blood stains. All right. Some of you said we're going to use the same temperature of the water in the washing machine. Why don't you be more specific? Are you going to use cold? Are you going to use warm? Are you going to use hot? Right? Why don't you tell me? Right? How long are you going to let the stains sit in the clothes before you wash them? Like I said, a lot of you said we're going to rub the stains in the clothes and let them sit for the same amount of time. Why don't you tell me how long? Say 6 hours. Okay. Some of you said we're going to use the same kind of clothes in every trial. That's great. Why don't you tell me that you're going to use a white cotton t-shirt? That's an even better answer. What I'm telling you is that when you set up an experiment like this, is that your answers will be better the more specific they are. I will give you more credit when you give me more specific answers instead of just saying things in general. All right, number 10, when your experiment is over, how will you know if your experiment supported or rejected your hypothesis? Well, in this case, if you set up the shading scale like we talked about before, then what you can do is say, I ran 10 shirts without without detergent and just water, 10 shirts with phosphate detergent, and 10 shirts with non-phosphate detergent, eco-friendly detergent. And then after each experiment was over, you took that stain and compared it to your shading scale. You could write down the numbers. And then if you did 10 shirts for each section, you could take an average of what those numbers were. So for example, if you had 10 shirts that were just in water, like you say, that shirt's a 7, that's a 5, that's a 4, that one's a 7, that one's a 7, and you'd have 10 different answers. You'd add them all up, divide by 10, and then you'd have a average score for that trial. You could do the same thing for the phosphate, and then you could do the same thing for the non-phosphate, and then you would have 3 numbers to look at. You can compare the average for just water, the average for phosphate detergent, and the average for non-phosphate detergent. So hopefully by going over the answers to this experiment, you are able to learn maybe how to improve your ability to do an assignment like this in the future. And of course, one thing that I'm going to ask you to do here is to make a flip grid that explains what you've learned post your first attempt to put this together, and explain what mistakes you've made and how you would do it better in the future, or what you've learned and understand better now that you've gone through the process and heard the explanation as to actually how to do it correctly. Thanks.